Hello and welcome to my first video in a series of videos on instrument flight rules, virtual training. My name is Tamer Magdi. I am a holder of a private pilot license, and I have also about over 100 hours of pilot and command flights and on my logbook, and also have over 35 hours of instrument flight training, and I've already passed 6 airline transport pilot license subjects on my way to get my airline transport pilot license, or ATPL. And I wanted to pretty much convert my practical IFR training, or instrument flight rules training, or the ground school and actual flying, into a series of videos, instructional videos, where I can explain a little bit about the theory, pretty much like what I have been taught, and also show the actual application of this theory in flight using Explain software as a tool to make sure that not only that you can you do understand the actual subject matter or the concepts that are being presented, but you can actually apply them while you are in flight on the spot. Because a lot of people would understand a certain concept during ground school while they're studying the actual theory or the concept they're dealing with, but when they're actually in flight and you have to implement it on the spot, they're having a hard time, and I'm going to teach you tricks on how to overcome this. Okay, so the first video, I'm going to start with VORs. And what is a VOR? It's actually, this stands for a VHF, or very high frequency omnidirectional range. This is what it looks like on the ground, if you've seen one. And mostly, if you have done some real flying, you probably see it from up high when you're flying over a VOR. The VOR basics that I wanted to talk about are that it does fall in a very high frequency range, which is why it's called VHF. The very high frequency range falls between 30 and 300 megahertz. That doesn't mean that the VOR frequency itself actually spans that entire range, but it does fall within that range, which is why it's called VOR, or VHF, very high frequency. The VOR signals, what you saw here, this station pretty much emits 2 different signals. One is called, or sends 2 different signals. One's called a reference signal. One's called a bearing or a variable signal. Now, the phase difference between the two, the reference and bearing signals, is what gives you the radial. Again, some of you might think, okay, this is boring, this is too much theory, but these are very basic concepts that you need to be aware of in general before you tackle the actual usage of VORs while you are in the cockpit. Okay, now what is the VOR frequency range, and why do I have to emphasize this? It's very important that when you are planning your flight and you pull out a map and you see the symbol for a VOR, to understand just by looking at the frequency, what type of VOR that you're looking at, and whether you're going to be able to use it for navigation, en route navigation during your flight, or if it's just a terminal VOR that's used for, non-precision instrument approaches, for example. So if the VOR signal falls between 108 and 111.975 megahertz, this is actually an approach VOR, or an ILS, instrument landing system frequency. I'm going to talk about ILS later, but let's focus on VORs right now. And if the frequency range of the frequency falls within the range of 112 to 118 megahertz, that is an en-route VOR that can be used for navigation over, definitely long distances, that you can actually be able to pick up the frequency in your cockpit. Anything higher than 118 is actually reserved for approach control. Now, what are the different types of VORs? There's en-route VORs used for navigation, which, as I said before, they fall between 112 and 118 megahertz frequency. There are also terminal VORs, and they are represented by TVOR. So when you see the abbreviation TVOR, you understand you're dealing with a terminal VOR. And I always get that confused with the test VOR that you see on the bottom, the VOT. But when you see TVOR, that's a terminal VOR. The VOT, it's a test VOR. And also there's the broadcaster BVORs, and this is actually what you listen to your ADAS on while you're in the cockpit for an airport. Information about the runway news, etc., etc. That's called a broadcast VOR, and that is used to actually transmit the ADAS that you listen to in the cockpit. So as you can see, there are 4 different types. And of course, in order to be able to utilize the usage of VORs effectively, we need to understand what are the factors that affect the accuracy, or being able to actually pick up a signal and be able to use the VOR while in flight. There's bending of the signal over terrain. That's a problem. And reflections from the ground, reflections from buildings, which is why, for example, let's say you're on the ground, you are typically within the range of an en-route VOR, but you try to tune in that frequency in the cockpit, and you get a failure flag, and you're wondering why. Is because there are reflections from buildings, there's bending over terrain, etc., etc. Once you are airborne, you find yourself that, whoa, I can pick up the signal now, and we'll talk about that in just a sec, how you have to tune in and identify. There's also oscillatory deviations called scalloping. That's a problem when the needle keeps scalloping back and forth. And there's also error from your airborne equipment. And beyond that, VOR protection range, and I'm going to show you how to calculate the range of a VOR. You get interference from other transmitters. So also that's something to be aware of, that, for example, if you are flying in a mountains area, for example, between mountains in valleys, and your VOR lies on the other side of a mountain, you're wondering, like, why am I not picking up the signal? Maybe you need to go up higher altitude to get a line of sight and be able to pick up the signal and actually utilize that VOR for navigation. Now, we talked about radials. What's going on? What is a VOR in general? How do you utilize it? Well, what it does is you have these radials coming out of that VOR station. As you can see here, the 000 radial goes up straight up, as you can see here, and you just go all the way around. And these radials are like, imagine them like imaginary arrows coming out from the center, and these are the radials that we refer to when we talk about VORs. One thing to make sure that you understand fully and thoroughly, that these radials are magnetic bearings. They are not true bearings, meaning you have a map, Lamport chart, or any type of map that you're looking at, and the map is drawn with true directions, and you see a VOR on it, and you see you want to calculate radials with respect to, let's say you draw a track on the map, and that track you try to measure the direction of the track based on the true direction from the map itself. That has to be converted into a magnetic bearing using the magnetic variation for that area that you're flying in. But usually when you see the radials drawn out from a VOR station on a map itself, you need to understand and fully understand that these are magnetic bearings. How do we calculate the range of a VOR station? Simple formula that depends on the height of the transmitter itself, the VOR station, and the height of the receiver, yourself in the plane, in the cockpit, flying at a certain altitude. And you don't understand whether you are within the range of the VOR or not within the range of the VOR. So the simple formula is you're gonna first calculate the square root of the height of the transmitter above mean sea level in feet. So you get a value. Calculate the square root of the height of the receiver, which is your plane, above the mean sea level in feet. These two values, you add them up, you get a sum, and you multiply this by 1.23. That gives you the range of that VOR station that you are dealing with. Now, a very important concept that we need to understand, the VOR, as I said before, has these radials that are coming out, and you do have an indicator in the cockpit, and I'm going to show this in detail in just a few minutes, that says to or from. Now let's look at a simple example. If I am choosing the radial 050 as my radial of choice that I want to get on for some like inbound or outbound, if you are if your aircraft is anywhere in that pink region, which is 050 plus or minus 90 degrees, you will get a from indication on the VOR. A from indication on the VOR. If you're choosing this radial, the 050, and your aircraft happens to be in the blue section, you will get a 2 indication in the cockpit on your VOR receiver. So the blue would be a 2 and the pink would be a red, it would be a from if you selected the 050. So the radial that you select, plus or minus 90 degrees, if your aircraft is within anywhere in that range, in that area, you're going to get a from indication, and you get a 2 indication if you're in the blue area. Let's look at another example. Let's look at an easy one. If we pick, for example, the 000 radial, or 360, as you can see here. That's my radial of choice that I selected on my using my OBS and the course deviation indicator, the CDI, in the plane, which I'm going to show in just a second. We're just talking theory right now. I select 360. Plus or minus 90 degrees will be what? Will be 090, as you can see here, and 270. So if I am in that upper half of that circle, anywhere with my aircraft, and I've selected the 360, I would get a from indication. If I am anywhere between the 090 and the 270 range, my aircraft is anywhere here, I would get a 2 indication. Let's look for another example so we understand this thoroughly. Let's say my radial of choice is 230. Okay, I selected 230 using my OBS and the CDI and the course deviation indicator. So that means if I am selecting the 230, if I'm anywhere in that blue section, my aircraft lies anywhere in that, on that side, which is between 140 and 320 in the blue side, that will be a from indication. If I'm in the pink side, it will be a 2 indication. Again, these seem to be like very dry, very harsh theoretical concepts that are very hard to grasp, but trust me, just follow this video towards the end, and we're going to apply this so many times that it's going to be like something that you don't even have to think about. You to completely realize it and understand and be able to implement it in the cockpit in just a second. So the radial that you select, plus or minus 90 degrees, if your aircraft anywhere in the range, you'll get a from indication. If your aircraft is in the other side, you get a 2 indication. Let's look for another example. Let's say I select the 090 radial. That means if I'm anywhere between the 360 or the 000 and the 180, my aircraft falls anywhere in there on that side, I will get a from indication. If I'm on the other side here between the 180 and 360, my aircraft will get a 2 indication if that's the selected radial, and I'll explain that in detail in just a minute. All right, tracking. The most basic thing with a VOR, we're not talking right now about catching inbound and outbound specific radials. I'm just talking about there's a VOR station, you want to fly to it and you want to fly away from it. What you're going to do is, first thing, you're going to turn your OBS in the plane until you get a from indicator and the needle is centered. The needle is centered and you get a from indication. That means you are on that radial. Let's go back again here. Let's say I am here on the 020 radial. I'm on it. I don't know if I'm on it or not. I have no idea where I'm at, but I am actually on it. I want to find out where I'm at. I take the OBS. I keep turning the OBS. Keep putting different numbers. I put 180 in the center. It's going to show a 2 and the needle is not centered. I keep turning it, going up until I finally or suddenly I find like, oh, the needle is now centered and is showing from on the 020. That means I am on the 020 radial. That means I am right here in the pink part on the 020 radial. And as I'm rotating the needle, I mean the selector, and I find myself, oh my god, the needle is centered on the 200, but I'm getting a 2 indication, not a from. Why? Why am I getting a 2 indication, not a from? Well, we talked about this before. We said if I select the 200 plus or minus 180, I'm sorry, plus or minus 90, so that's 290 right here, as you can see, and 110. If I'm anywhere on this side, it's a from, but if I'm on the other side, it's a 2. That's why I'll find that when I am here on the 020 radial and the needle is centered at 200, I'm getting a 2 indication because I'm on the opposite side. We don't want to get too much into this for now. We're going to explain these concepts in detail, but I'm showing the most basic thing. Turn the OBS, keep turning it until the needle is centered and you're getting a from indication. That means you are now at this moment on that radial, period. So if I am here on the 020, if I want to fly away from that VOR, I will fly the heading 020 with my aircraft. I'll be flying away from the VOR. When I fly to the VOR, apply the reciprocal. The reciprocal is 200 and will take me to the VOR station. Or simply keep turning the OBS until you get the needle centered at 200 and it shows a 2 indicator, which means to the VOR station is the 200 heading, or to be more accurate, is the magnetic bearing that you need to follow. The heading of the plane might be a little bit slightly different according to the compensation for the wind, and we'll get to that later also. So I'm gonna now give you a detailed explanation about the radials, your position, and what the indicators mean in just a second, but needed you to understand basic concepts here, which is, why is it called a VOR? What are the types of different VORs? The frequency ranges of VORs, factors affecting the accuracy of VORs. What are these radials that we're talking about that are sticking out of that center or from the station itself, the VOR station? What do they mean? And what is a from or a to indicator mean that you get in the cockpit, so you understand what from means when you see it, what to means when you see it. And finally here, as you can see, how to fly away or towards a VOR station, which is called tracking, how to track a VOR. And now we're gonna move on to the next part of this lesson, where I'm gonna show you actual examples. We're gonna move the aircraft all the way around, and you'll be able to see what the indicator is going to be, or the indication is going to be in the cockpit on your CDR, course deviation indicator, and you'll be able to actually try to implement these concepts in just a second. Okay, we'll continue now. Okay, so now we're gonna look at examples so that we can understand the actual concepts that we just talked about right now. On the top, as you can see, this is your course deviation indicator, which gives you the from and the to flag, and that's the one you use to select a specific radial that you want to intercept, whether inbound and outbound. We're not going to talk about this right now, but let's say you select a specific radial using the OBS. As you can see here, look, I'm rotating the actually direction of the radials on top that I want to select, and we're gonna use that to select a specific radial. And based on the location of the plane on the bottom half, that's the VOR station is in the center. That is the symbol of a VOR that you'd see on a map, at the right in the center, and this is where the aircraft is. And we're gonna start with simple concepts, like we talked, like what we said before, what we talked about. Let's say here's the aircraft is on the 060 radial. We said, oh, let's start with something maybe easier. Let's start with the 000, as you can see here. All right, we said from the previous slides that if I am on this radial and I select it using the OBS, as you can see here, That means if I am on that radial, the needle will be centered and I would get a from indication. Okay, now let's try to move the aircraft around to show the concept of from indicator and a to indicator. We said if I'm selecting the 0, 0, 0 radial, which is north, as you can see on the top half of this illustration, that means if the aircraft is anywhere between the 090 and the 270 on the top half of the circle, I would still get a from indication. On the opposite side, or the bottom half between 090 and 270, I would get a to indication. Let's try this. Here's the aircraft. Let's pay attention to the from and the to. That's all I need you to pay attention to right now. So I'm here. Look, anywhere here on this bottom, the top half of that circle, the from indication is still there. Watch what happens when I move the aircraft now between 090 and 270 on the bottom half of the circle. Watch what happens with like 2. Anywhere I'm on the bottom, I get a 2. And one more thing you need to pay attention to. Your aircraft hitting doesn't mean anything here. Look, the aircraft could be turning around like this. Doesn't matter. What matters, imagine your aircraft being like a dot, like a little point, and that point what matters whether the point is on the radial or not. Your heading is not a factor here at all for the indication you're going to get on your CDR, course deviation indicator, that you see on the upper half of this illustration. Back again. Anywhere here, it's still a to. Anywhere on the top, it's a from. Let's pick another radial. Let's pick radial 060. Okay, so plus or minus 90 degrees, 60 plus 90 is 150. 60 minus 90 will get 330. So if I'm anywhere here, it's a from. Look at the aircraft. The aircraft is anywhere in the side, that half circle, that slice between the 330 and 150, getting a from. Watch what happens when I jump to the other side. It's a to indication. It's a to indication. Again, heading doesn't mean anything. Your heading of your aircraft doesn't matter at all here. What matters with the aircraft is if it's like a little circle or a dot or a point, what matters is where it is with respect to the selected radial. Select a 060, all this is a to. Come to this side now, it's a from. Again, I'm focusing only now on the from and the to indications that you get in the cockpit so you can understand the concept thoroughly. Now let's pick another one. Let me ask you a question now. If I pick the 090 or east, so I should get a from indication where 090, 90 degrees plus or minus 90, anywhere between 0 and 180. If the aircraft is anywhere in that right half of that circle, I would get a from indication. If I go the opposite side, between 180 and the 360, I'd get a to indication, right? And let's look. Aircraft anywhere here, you're still from. Jump to the other side, it's a to. Look, anywhere here, it's a to. Come back here, it's a from indication. Do another example. Something, maybe let's go to 150. Right? 150 plus or minus 90. 150 plus 90 is 240. 150 minus 90 would be 60. So anywhere between 060 and 240, this bar right here, I'm getting a from indication. And if I am on the opposite side, I would get a to indication, as you can see here, between 240 and 060. Anywhere on that side, it's a to. Anywhere on this side is a from. This is very important for you to visualize or understand the concept of from and to based on the selected radial. Select any radial you like. Select the 240 without moving the aircraft. What's happening here? 240 plus or minus 90. That would be 150 and 330. if I'm anywhere between the 150 and the 330, I would get a from. If I'm anywhere between the 330 and the 150, I get a 2. Okay, so let's test this. Anywhere between the 150 and the 330, here's the aircraft, I am getting a from indication. Go to this side now, between 330 and 150, I'm getting a 2 indication, period. So, I am now here. I'm flying with my aircraft. I don't know where I'm at with respect to this VOR. I tuned in the frequency. I identified that VOR station. And I want to know, where am I with respect to this VOR? We're going to follow the steps that we talked about previously in the previous slides when we said we're going to keep turning the OBS until we get the needle centered and a from. This is a 2. It's not what we're looking for. We're looking for a from indication and the needle centered. Keep turning this in the plane. I'm in the plane now. I'm doing the OBS. Boom. Needle is centered. I'm getting a from indication. I am definitely between, I would say the 115. I'm on the 115 radial. And indeed, look at the plane. You are pretty much on the 115 radial coming out of the VOR. Now, I told you the heading doesn't matter. Look, I'm going to now turn the plane around 360 degrees on the same radial. Look at the top half. Look at your CDI, your course deviation indicator on the top. Nothing's going to change. Here you go. Look at the plane. Facing anywhere. Anywhere. Doesn't matter. What matters is that plane, as if it's like a slab of metal, or a point, or a circle, or a dot, whatever you want to imagine it, whatever is easier for you to actually imagine or visualize and understand, nothing is changing on the indicator. You know why? Because the plane is still on the same radial. The plane is still on the same radial, facing in any direction. It doesn't matter whatsoever. Another example. I am flying now with my plane anywhere. I don't know where I'm at. I know there's the VOR station. I'm within range. I tuned it, put the frequency for it. I identified it. And now I'll find out where am I with respect to this VOR. Simple. Follow the rules. Take your OBS indicator, keep turning it around until you get a from indication and the needle is centered. Boom. I must be on the 245 radial. Boom. Indeed I am. Look at that. Look at the bottom half. On the 245 radial coming out of the VOR. Doesn't matter what my heading is. I'm flying. All I know is I'm on the 245 radial. And like we said before, what happens if I want to fly away from the VOR, fly the 245 heading. I'm going to be flying straight away from the VOR. And what happens if I want to fly towards the VOR? I'm going to fly the reciprocal of 245. Reciprocal of 245, I believe, is 065. So if I turn to 065 with my plane, say I'm going to fly 065 direction, it's going to take me straight to the VOR. And indeed, if I turn the OBS to 065, I'm getting the needle centered and a 2 indication. Why? Because the 060 plus or minus 90 is 150 and 330. Or 65, I'm sorry, it will be 155 and 335. If I'm on that half, it will be a from. If I'm on the other side, it will be a 2. So that's correct. And if I turn my plane heading to 065, I'm going to fly straight to that VOR as long as I keep that needle centered the way it is. Another example. I am somewhere flying my plane. I don't know where I'm at. I'm not going to look at the bottom half now. Let's look at the top half. I'm in the plane now. I'm flying. I know there's a VOR station. I'm within range. I tuned it. I identified it. Now I'm going to keep turning my OBS until I get the needle centered and I get a from indication. A from, not a 2. We keep turning. Here's the from indication. Boom. Here I am. Okay, I'm approximately here on, the 290 radial. And indeed, you look in the bottom half of this illustration, you see that I'm on the 290 radial. And again, the heading itself doesn't matter. The top indicator will not change. Nothing is happening because I am still on the same radial, facing any direction. That's not an issue here. And if I want to fly towards the VOR, I fly the reciprocal of 290. What is the reciprocal of 290? As you can see here, I'm going to find out simply by turning the needle to be centered and put a 2. Here we go. That's 110. If I fly heading 110 with my plane, I'm going to fly straight towards the VOR. If I fly the opposite heading, which is the radial I'm on, with the from indication, as you can see here, keep turning, I fly 290. Exactly. Turn the plane around. I'm flying 290. I am flying away from the VOR or from the VOR. Okay, so it's very critical that you understand the concepts of from versus to. What does a from indication mean? What does a to indication mean? And grasp the important concept that the heading of your plane does not matter. The plane could be facing anywhere, it doesn't matter. What matters is the radial the plane lies on at that moment. And this is how it works. You are flying, and if you want to use a VOR and find out where you are with respect to that VOR, you keep turning. Here you go, and just put the plane anywhere. Here we go, put it here for example. Turn the OBS, keep turning the OBS until I get a from indication. A from indication, here we go, a from, and the needle is centered. Here's the needle centered. I think this looks like what, 225. So okay, so I'm on the 225 radial from the VOR. Want to fly away from the VOR, straight away, I fly 225. Want to fly straight towards the VOR, it's the reciprocal of 225, and it's just by turning this and making it a 2 and the needle centered. Here we go, that's 045, and that would take me straight to the plane, to the VOR station. Turning the plane now. Let's say I'm flying out, I want to fly towards this VOR. Here we go, I'm going to face 045, fly straight ahead, I'm going to fly towards the VOR station. Very important concepts to grasp. Your heading does not affect the indication you get on the top. What matters is which radial the plane is currently on, actually lies on at the moment. And that's how you get the indication you're looking for. Okay, so now that we covered the concepts of from and to, how does it work, and how to fly to or track away or towards a VOR station. Now there is the concept of intercepting radials. You're flying somewhere, you've been told by ATC, hey, you need to intercept radial 090 outbound or 090 inbound. What is 090 outbound, 090 inbound? Well, 090 outbound from the VOR is 090 from. That means that 090 going out, and 090 inbound is actually direction 270 if you are on that radial. It's the opposite direction, tracking towards the VOR. But they will not tell you to track in. If you're on this side, they can see track 090 inbound. So you come with your plane, and you come here and you track 090 inbound, as you can see here, and that's tracking the 090 inbound towards the VOR station. If they tell you to track 270 inbound, that's like here, and you're supposed to be flying towards the VOR station. 270 radial, 270 inbound. Why? Again, these are radials, not directions, in the sense that we're not telling you to go or to go towards heading 270. We say radial 270 inbound. This is a radial. Any radial is a line with an arrow sticking out of the VOR station itself. 270 radial is that line coming out of the VOR station going west. Till you track it 270 radial inbound, which means towards the VOR station. So that means you're going to fly this way. And now I'm flying on the 090 outbound. Again, see? So I came from here, 270 inbound. Once I pass over the VOR station, I am flying 090 outbound. Another example, you told track 060 outbound. Very simple. Here's 060, I'm on it. And now direction 060 outbound. This is the radial 060. I'm tracking it outbound. 060 inbound. Okay, that means I need to track the 060 inbound. coming this way and tracking the 060 inbound towards the station. Now I'm on the 240 outbound, as you can see, coming out. These are simple concepts or terminology you need to understand from ATC when you're told to track a specific radial. And of course, it's not going to be like this in the sense that you're going to be told to track an inbound or an outbound radial. There is a protocol. There's the right way of doing this and how to actually intercept the radial based on where you are. And that's what I'm going to talk about next. And of course, all these concepts you seem confused now. There's so much stuff to know. But then I'm going to show you how to implement these concepts using very simple tricks in the cockpit, where you can do this like second nature. It'll be very simple, and you follow these steps or rules in the cockpit, you'll be able to know where you are and which radial that ATC told you to intercept, and what is the proper way of intercepting the specific radial inbound or outbound. There are rules for this. I'll show you how to use them. But now that you grasp the concept of from versus to, and the fact that the heading of the plane doesn't matter when it comes to knowing which radial you're on. What matters is that the plane is carrying on the radial at the moment. It doesn't matter what heading it's actually facing or going towards, and at the same time also understanding what does a specific radial inbound or outbound mean. To track 090 inbound, you know which direction I'm talking about, 090 outbound, which direction I'm talking about, 060 inbound versus outbound, what it means. What the from and to indications mean if you want to track towards a VOR or away from a VOR. Okay, so now that we pretty much grasp the concepts of from versus to indicators, and also we grasp the concept of what it means for it to be on a specific radial, and that the heading of the aircraft doesn't matter. What matters is the actual radial the aircraft is currently on. And we got an idea of what it means to intercept the radial inbound versus outbound. There are protocols, or there's a protocol to intercept those radials, depending on where the aircraft is at the time you've been instructed by ATC to do that interception, whether it's outbound or inbound. And I'm going to start with the easy case first, the easy case of intercepting an outbound radial. All right, let's say the ATC has instructed you to intercept radial 180 outbound. As you can see here from the picture, it's that line coming straight down from the VOR, going south. That's the radial that you need to track or to intercept and track outbound, which means away from the VOR. So depending on where you are, there's a protocol to intercept that radial. If you are within plus or minus 90 degrees from that radial, so if I'm anywhere between 090 and 270, I need to come at it with a 45-degree angle until I intercept it and then fly straight in the direction of that radial away from the VOR. Okay, but that's one case. But if I am on the opposite side of the radial, which means for example in this case between 270 and all the way to the other side to 090, in that case, the first thing I'm going to have to do is to fly in the same direction of the radial, which is here. It's 180, so I'm going to fly south 180 until I'm A-beam from the VOR. And once I'm A-beam from the VOR, I turn 45 degrees towards that radial, and I intercept it, and then I fly away, and I track it away from the VOR. Okay, so this is the simple case scenario for intercepting an outbound radial. If I am plus or minus 90 degrees from that radial, I just go ahead and come at it at a 45-degree angle, intercept it going outbound. If I'm on the opposite side, I need to fly in the same direction of that radial first until I'm A-beam from the VOR. Then afterwards, I'm going to come at it with a 45-degree angle, and I keep flying until I intercept it. The needle is centered, and I just keep tracking it going south away from the VOR. That's one example. Again, I understand that how you're probably thinking right now, how am I going to be able to do all these calculations in my head while I'm flying? I'm managing my speed, I'm managing my altitude, I need to maintain heading, I need to do all these things in the cockpit, I'm scanning the instruments. I've been instructed by ATC to do something like this, but I will show you tricks that you're going to be able to do in the cockpit that will allow you or enable you to do these calculations just visually, and you'll be able to know exactly what you need to do and how to intercept those radials in the proper fashion without having to worry about all these you know, the overwhelming amount of information I'm throwing at you right now. But you need to understand these concepts first, and then when we implement them in the aircraft, in the cockpit, they're going to see much simpler, following the simple rules I have outlined briefly in this video, and you'll see how I'm going to actually use them practically in the cockpit when we go to the explain simulator, and I'm going to show you how to use them. So that's the case of intercepting an outbound radial. Again, not that complicated. Plus or minus 90 degrees from the radial, just come at it with 45 degrees. If I am the opposite side, I'm going to fly in the same direction of that radial I've instructed to intercept, an outbound radial, not an inbound, outbound radial, until I'm A-beam from the VOR. Once I'm A-beam from the VOR, I'm going to fly 45 degrees to intercept it, and once I intercept it, I fly in that direction away from the VOR. Okay, now we come to the little bit more subtle, more complicated interceptions, which intercepting inbound radials. Okay, the way it works here, let's say you've been instructed by ATC in this example to intercept radial 180 inbound. So here's the 180 inbound coming, okay, coming, that's the south one, and it's coming, it said inbound, it's towards the VOR. This is the radial 180 coming out of the VOR south, but I need to intercept it going inbound, which means towards the VOR. And then the protocol or the proper way to intercept this radial depends on where you are. And the way it works is, if you are plus or minus 30 degrees from that radial, as you can see here, you're going to come at it at 45 degrees, and you're going to intercept it at 45 degrees, and then you intercept it. If you're between 30 to 60 degrees, you're going to come perpendicular to it, or A-beam to it. Okay, you're going to fly perpendicular to it until you're 30 degrees from it, and that's when you turn 45 degrees towards that radial and intercept it. And if you are anywhere else higher than 60 degrees, what you're going to do is you're going to fly in the opposite direction of that inbound, which means here, if 180 inbound, which means you're going to fly in 180, you're going to fly straight south. Once you're 60 degrees away, you're going to boom, turn 90 degrees left, until you're 30 degrees away, and then at that point you're going to turn to intercept it at 45 degrees. That's how it works. Again, it seems like, oh, that sounds so complicated. How am I going to be able to do all these calculations in the cockpit? Simple tricks I'm going to show you. Just a few minutes. I'm going to implement these concepts. We're going to be able to intercept these radials properly. And the reason why we need to master these interceptions, master the understanding of what the CDI tells me about where I'm at with respect to the VOR, the course deviation indicator in the cockpit, is it's very critical to understand these concepts, because you're going to use them later. And when you do holdings, when you're instructed by ATC to hold at a certain fix, and you're given the inbound leg, and I'm going to do a video later on how to do proper holdings. For now, the most important thing is to find out where you are with respect to the VOR. Once you find out where you are with respect to the VOR, you've been instructed to intercept a specific radial outbound or inbound. The outbound, we talked about that. It's the simple case. If I'm plus or minus 90 degrees from the radial, I'm going to come at it at 45 degrees, intercept it, and fly away, fly on it. And if I'm on the opposite side, I'm going to come in the same direction of the radial until I'm A-beam from the VOR. And once I'm A-beam from the VOR, I'm going to turn 45 degrees to intercept that radial. Inbound, all I care about here is if I'm within 30 degrees or 60 degrees or higher. Anything higher than 60 degrees, I'm going to fly in the opposite direction of that inbound radial. And then once I'm 60 degrees from that radial, I'm going to turn 90 degrees towards it. Once I'm 30 degrees towards it, I'm going to turn another 45 degrees and intercept it. And that's how you properly intercept or you track an inbound radial if you're instructed by ATC. And all it depends on where you are when you're instructed to do that. As you can see in this picture, you are, let's say you are heading in any direction. It doesn't matter what direction you're on, but all that matters if you're in a specific sector. These are the, see here, let's say I've been instructed when I'm here, the aircraft is in section 2, and you're going away from the VOR. You've been instructed to intercept radial 180 inbound. First thing, oh, I found out now I'm between 30 and 60, so I'm going to fly like perpendicular to it first, that is 090, until I'm 30 degrees away from it. Boom, I turn 45 degrees left, and then at that point I'm flying in the direction 045, and then intercept the radial 180 inbound, and then fly straight up towards, or straight ahead towards the VOR. Let's say if I'm in section 3, I'm flying in any let's say I'm in a direction, instruct ATC intercept radial 180 inbound. Okay, I know that I am higher than 60 degrees. I'll fly opposite of it, which is 180. I'm going to fly straight south until I'm 60 degrees away. You know, once I'm 60 degrees, within 60 degrees or so, and then I'm going to go ahead and turn perpendicular to it. I'm going to turn 90 degrees left, and then I'm going to continue until I'm 30 degrees from that radial, and then I'm going to turn 45 degrees to intercept it. Sounds very complicated, I understand, but I'm going to show you tricks on how to use these concepts and implement these concepts in the cockpit very easily when you instruct it to intercept certain radials using all the different, you know, the CDIs in the aircraft that you have, and how to use them as if you are actually drawing the situation and actually implementing it so that you can actually follow the ATC instructions properly. And now we're going to move to the actual cockpit in the X-plane of a Cessna 172 and do some training flights to implement these concepts. Okay, we're back again. Now we are going to try to practically implement what we've learned about interceptions and radials, VOR radials in general, while we're flying in an aircraft. I do understand that up to this point there were so many different methodologies or protocols of intercepting radials, inbound and outbound, that have been sort of like thrown at you, and you're thinking to yourself like, okay, how am I going to be able to do all this within an aircraft while I'm flying, and I have to, for example, maintain heading, maintain my altitude, and so forth, and keep monitoring all my instruments. Well, there are there are tricks to do this, which I'm going to show you right now. Okay, so first of all, where are we? Now we are at an airfield in Hungary, Lima Hotel Bravo Sierra, LHBS, right here. This is a grass airfield, and we're gonna take off in just a few minutes and do our training at Papa Tango Bravo VOR. And before I take off, I don't want to use the GPS. We're not going to use the GPS. We're gonna pretty much rely on the concepts that we've learned. The first thing we need to do is to tune in the VOR station frequency, which is 117.1, and you can see here is Papa Tango Bravo. And once you tune in the frequency for the VOR, the first thing you have to do is to go and identify the VOR by listening to the Morse code, which is dots and dashes, for that particular VOR station. Once you can hear it clearly, that means it's operational and it's functional. We're going to turn that off, and then we come back again to our display here. Obviously, in X-plane, in the Garmin 530 or 430, it does show you, for example, which radial you are currently on. I'm not concerned about this. We're not going to use this at all. Instead, we're going to use the CDI. The CDI is the course deviation indicator. Let me zoom in on that one. This is what we're going to use in order to navigate using the VOR station that has just been tuned in. And I am going also to use the ADF, the automatic direction finder, just the indicator here. It's not tuned into any station. This is used with NDBs or non-directional beacons, which will be discussed in a future video. I'm just going to use this as a device to guide me on where I'm at, where I need to go, instead of using a pen and a piece of paper. So this is actually not connected to anything right now. It's as if it's like turned off, and I'm going to use the ADF right here, and I'm going to show you how, instead of using a pen and a piece of paper in a plane, when you're being instructed by ETC, for example, to intercept an inbound or an outbound radial from wherever you are, we're going to use some tricks to be able to figure out what we need to do next according to the steps that were shown in previously on how to intercept an outbound radial or an inbound radial. Okay, so let's get the aircraft ready for takeoff first. And again, this video is not concerned about the handling of the aircraft itself, and meaning like, you know, how to operate and turn and so forth. So I'm going to be using the autopilot for most of these functions. All I need to do is just climb up to 3,000 feet, and I have to stay below 3,500 feet because this airfield is very close to
the Budapest International Airport, and the TMA in that area where that airfield is, it starts at a lower level of 3,500 feet, so we have to stay below the TMA, as you obviously know. Okay, so to get the aircraft ready, I'm gonna put flaps 1. I'm gonna start setting up the autopilot. I want to maintain heading, and I want to climb at 500 feet per minute. As you can see here, my heading bug on directional gyro or directional indicator, as you can see here, is set to west, which is the runway we're on, 27. We're on runway 27 left, facing west right now, and we're about to take off. I made the weather conditions to be foggy because I don't want us to see anything outside the plane. I want us to navigate our way around using only the CDI, or the course deviation indicator. So again, you've heard me use this terminology before: a CDI, an OBS, and an ADF. This is a CDI. It's called the course deviation indicator because it tells you how much you're deviating from a specific course, and it can tell you where you are with respect to a tuned-in VOR. This is also a CDI. It's a different type. As you can see, it doesn't have a horizontal indicator. And on the bottom here, this is the ADF, which you tune into an NDB frequency. Will be discussed later. And again, we're going to use this dial just simply as a cheat sheet, but it's not connected to anything. And I'm going to show you how to do this right now. The middle CDI, we're not, we can use that one, or we can use the one on top, but I am mainly concerned with the one on top here, because in the future when we discuss ILS or instrument landing systems, that we're going to also use the horizontal indicator. And if we zoom in, you will see that there are dots, and we can count them. There are 5 dots on each side. Each dot indicates that you are off by 2 degrees from the selected radial. Meaning, if, for example, this needle is on the second dot, and I'm selecting the 000 radial, or north, for example, and if I'm here, that means I'm off by 2 degrees on the first dot, I'm off by 4 degrees on the second dot, and so forth, 2 degrees per dot. Anything with 5 dots or more is going to be 10 degrees or more, so at that point I'm greater than 10 degree deviation, and I will have to adjust accordingly. Okay, let's get the aircraft ready. Flaps 1, heading set, climb rate of 500 feet per minute. We just need to disconnect the brakes and take off, and then turn the autopilot on and head towards our VOR station and start doing some exercises, interception exercises right now. Okay, brakes released, as you can see. Alright, advancing the throttle with a little bit of right rudder to maintain our direction or heading. And when we get to 60, we pull on the stick a little, and we establish positive climb. And at that point, I'm going to turn on the autopilot, as you can see. And now the aircraft is climbing at 500 feet per minute and maintaining the heading. And I'm then going to retract the flaps. Okay, and once I'm at 1,000 feet, I'm going to turn south, and then we're going to start doing some interceptions and doing the steps that we've discussed earlier. Okay, now we're almost reaching 1,000 feet. We're not looking outside, disregarding all these illusions. And now I'm going to turn south. Video about the autopilot, of course, once you select a specific heading, the aircraft will turn, will do a rate 1 turn, as you can see here, where the wings, the turn indicator will show you that the wing is aligned with the dot right here, and that means you're doing a rate 1 turn. Okay, so we're climbing. We gotta keep an eye on our altitude indicator, and we're gonna go ahead now and start doing some exercises. Okay, so first thing, let's say you've been instructed by ETC to intercept, for example, radial, let's say 300 inbound. 300 inbound. First thing, you tune in and identify, as I've discussed before. That's the most important step that you have to start with. You tune in the frequency of your VOR station, which is here 117.1, and then you listen to the Morse code of the frequency in your aircraft to make sure that it's operational. And once you've done with these very initial steps that have to be done pretty much every time, what you're going to do is you need to find out where you are and put that radial that you've been instructed to intercept, whether it's inbound or outbound by ETC, on top on your ADF dial right here. We've been instructed to intercept 300 inbound. So what I'm going to do is I'm going to put 300 on the top right here. This doesn't mean anything. This is just like a cheat sheet. I'm going to use it to find out where I'm at and where I need to go. Okay, so after that, I am going to use the OBS, the Omni Bearing Selector, to keep turning it until I get a from indication and the needle is centered. Here we go. I have now a from indication and the needle is centered. That means I am currently on that radial. I'm pretty much on the 020 radial, 022 radial, as you can see, and of course I keep moving and it's changing. Then I come back here to my cheat sheet. This is the one I want to intercept inbound, meaning I want to intercept this radial going down towards the VOR station. So imagine the center is the VOR station, and I want to intercept this radial and go inbound towards the VOR station. We've said right now that we are currently or physically on, let's say, on the 020 radial. Here's the 020 radial. We are here. We now follow the steps that we've learned about intercepting inbound radials, and we're going to measure. Here's 30 degrees, 300 to 330. There's another 30 degrees. Okay, so the first thing we're going to do is we're going to have to fly opposite of the inbound radial, okay, and parallel to it. Okay, so that means we're going to have to fly 300 direction. That's the first thing, 300. Then we're going to go horizontal or A-beam to it, and then we're going to intercept inbound. So let's go ahead now and fly in the 300 direction. Here we go, back here, turning to the 300 direction. Okay, we're approaching 3,000 feet, and we have to make sure we maintain altitude. Just a second while we're turning. Okay, so I'm using the ADF, as you can see here. Look at the cursor or the mouse, and you will see that this is my cheat sheet. First thing I do is to set the radial that I've been instructed to intercept inbound or outbound on the top. 300 has been set on the top. Okay, so I reached 3,000 feet. I am going now to hold the altitude, and then we can focus on our flight. I'm going to go a little bit on high on the RPM right now. This is again not a video on how to operate the aircraft, more of like a video on how to navigate using the VOR. Very good. So back again to our cheat sheet. So at 60 degrees I have to go this direction. Okay, just like I have to go A-beam to it. What is this direction? It's 210. So when I hit this radial, the north, the 000 radial, I have to turn left to direction 210. Okay, going back here, so we're gonna have to put our 000 radial. This is the one that I need to, once I intercept this guy, I'm gonna turn like this, left, and then once I intercept the 330, which is 30 degrees from the one I want, I'm gonna turn 45 degrees to the left in order to intercept the 300 inbound. Again, this is following the steps that we've learned. You need to memorize the steps that I've shown you in the PowerPoint presentation a little while ago, how to intercept inbound radials. And once you understand these, to implement them, it's very simple to implement them if you use the ADF or any one of the dials that you have in the plane that you're not currently using or not tuned into anything. and to use it as a guide on how to navigate. We said we were initially at the 022 radial, and then we're going to have to go up this way until we hit the radial, the 000 radial. Then we're going to turn left this way. What is this direction? Oh, here it is, 210. The needle is moving closer, as you can see. Very good. That's what I was expecting. That means we're approaching the radial. We're about now, we're almost 5 degrees away. Now we're closing into 4 degrees. So I'm going to turn to 210. Okay, time to turn now to 210 so we can catch this guy. Here we go. Now I'm turning to 210. Back again. Why am I turning to 210? We're following the steps. 30 degrees, 60 degrees. I'm higher than 60 degrees. I have to go opposite of the inbound radial. Here's the inbound radial in the direction towards the VOR. I'm going to go opposite of it to 300. I'm going to turn left 90 degrees until I hit the difference of 30 degrees here to the 330 radial. Then I'm going to intercept at 45 degrees. Okay, good. So now I've turned. I'm maintaining 210 heading. So the next radial I need to look for is the 330 radial. Come back here. Here we go. I'll set it on the top. And once I see the needle moving close to it, I'm going to start turning to capture it. And at that point, what am I going to do at the 330? At the 330 radial, I'm going to turn at 45 degrees to intercept the 300 inbound. What is 45 degrees? I mean, I don't need to do any calculations in my head whatsoever. All I need to do is to look at this dial. 45 degrees this way is right here. Here's the little orange marker. Right here. And it tells you that it's 160. So once I hit the 33 or go on the 330 radial, I need to turn 45 degrees this way to intercept this guy that I've been instructed to intercept by ATC and go south. I'm sorry, and go in that direction inbound in order to follow the ATC instructions. So I'm going to turn to 160 once this needle comes to the center. When we're done with the interception, I'm gonna bring the map back on, and we'll be able to take a look at what we've done and how we intercepted that 300 radial inbound. Again, can't see anything outside, and we don't use the GPS. We're mainly navigating using the VOR. The CDI tuned into a VOR station. Okay, as you can see now that the needle is starting to move, so I'm going to turn in the direction 160 once the needle is close to center. Okay, so now I am going to be physically on the 330 radial because I have a from indication the needle is centered, and I'm going to turn to 160. So I intercepted this one, and now I'm coming at my 300 inbound towards the VOR at 45 degrees, and I know the 45 degrees of this direction coming from here is simply 160, as you can tell from this little orange marker. Okay, so now what is the radial I need to intercept? I'm instructed to intercept by ATC is the 300. Now we're at the final step. We tune that in. We use the OBS to select the 300 radial, and we'll wait till until the needle starts to move and it's coming to the center. We intercept it by going inbound. See, 300 inbound is what direction? 120. The reciprocal. Right here. So I'm going to turn to 120, heading 120 once the needle is centered, in order to be able to intercept the 300 inbound. Again, not using a pen or a piece of paper, I'm in the plane. All I did was I used the ADF right here. It's not tuned into anything. It as a guide. I know where I'm at, I know where I need to go, and I know what the rules are, and I just follow this, and all the directions or the headings I need to turn into, I can just look at this simple dial and figure out where I need to go without doing any math whatsoever. Okay, now we're back again, and the needle is starting to move, and we're gonna intercept the 300 inbound, which is direction 120. It's time to turn slowly as the needle is getting close to the center. Here we go. We start turning now. Okay, it escaped a little. It's okay, we can adjust by moving a little bit farther this way until it comes back to the center, and then we go back to one direction or heading 120. Okay, what is 300 inbound? 300 inbound is a 300 from, but going the opposite direction, it's actually 1202. The reciprocal of this radial is 120. And that is the 300 inbound. Few adjustments. We're getting close, I believe, to the VOR, and the closer we are to the VOR, the more sensitive it becomes, because the angles or the distances between the radials become small. Okay, good. So now we're almost over the VOR, so it's gonna switch. Let's take a look at the map now, what we've done. This is exactly what we've done. Okay, we took off from Lima Hotel Bravo Sierra. We turned south, and then we were instructed by ATC to intercept 300 inbound. So what we did was we went in the 300 direction, which is opposite of the inbound, the 120. Then at 60 degrees from the radial that we need to intercept, we went A-beam to it, as you can see here. And right when we are 30 degrees from that radial, the 300 inbound, we came at it at 45 degrees, we intercepted it, and now we're flying towards the VOR station. That is the first example of interceptions. Now, let's do another example, maybe of an outbound interception. Okay, let's say now you are flying and you've been instructed by ATC to intercept radial 180 outbound. 180 outbound. First thing, you tune in and identify the station if you haven't done so already. Listen to the Morse code, make sure that it's operational. Second thing we're gonna do is we get that radial that we've been instructed to intercept, which whether it's inbound or outbound, you put it on the top on the ADF dial right here. So here it is, it's on the top, the 180. This time it's outbound, which means we're gonna go on this radial but outward, away from the VOR. So we're gonna go straight south, not inbound, which would have been north. Okay, so now we set that radial on the top. The next thing is obviously to figure out where we are. So we keep turning the OBS until the needle is centered, and we have a from indication. And I can see here I'm on the 125 radial, approximately. Very good. So come back here. I need to intercept this guy. I'm on the 125. I'm somewhere here. And according to the rules of intercepting outbound radials, if I'm on the bottom half right here, I would have had to go parallel to it until I am plus or minus 90 degrees, and then I intercept at 45. But I'm already on this side, so I have to intercept at 45. What is the 45 degrees that way? Nothing to think about, nothing to worry about. Just look here, 45 degrees, this way. Here's your little marker. That would be 225. So I need to turn right away to heading 225 to intercept that outbound radial. Here you go. I'm going to turn now. 225. Using my heading selector for the autopilot. And once I intercept the 180, and how do I know this? I go back to my OBS on the CDI and put it right here, select it. Once I see the needle moving towards the center, I'm going to turn into the outbound radial direction. I've intercepted my radial that I'm looking for, 180. I'm going to turn into the 180 heading, and at that point I've intercepted 180 outbound. So again, in summary, what's happening is I tune in and identify. I use any one of the dials in the plane that I'm not using, that's not tuned into anything, as my guide. In this case, I'm using the ADF. I put the radial I've been selected to intercept, whether it's inbound or outbound, at the top of my ADF, as you can see here. And right away I have a mental picture and an actual visual picture of what's happening. I need to find out where I'm at by using the OBS on the CDI until I get a from indication the needle is centered. At that point I know where I'm at. Come back here again to the ADF. I find out where I'm at, what I need to intercept, and following the rules from the previous slides that I've shown you, you just pretty much navigate and you know your directions just using this dial. You don't have to do any math. If I'm going this way, I'm going south. If I'm going 45 degrees this way, I'm going 225. If I'm going to the right, I'm going west, and so forth. Use this as your guide. So we are going to intercept 180 outbound, and then after that we will do another example in just a few minutes. Here we go. Now the needle is starting to move. We are about to intercept. We're getting very close to the 180 radial, and when I get close to it, I'm going to start turning to head in that direction because I'm going outbound, meaning in the 180 in the south direction. If it was inbound, I would have turned in the opposite direction, which is north. Okay, so it's turning now. I'm going to start turning here south very slowly. As you can see, it's a rate 1 turn as the needle is moving. Then start slowing down. Okay, we turned a little bit too early. Still, it's almost centered, so maybe we need to adjust a little bit to the right to follow the needle to bring it back closer. It's deviating to the right, and as it comes back to the center, we adjust back to our heading of 180. Here we go. Good. Now we come back to 180, needle centered, and let's take a look now at the map to see what we've done. Here we go. We were here flying in this direction. We were instructed by ATC to intercept 180 outbound, and we came at it with 45 degrees, as you can see. And then once we intercepted, now we are going in that direction, 180 radial outbound, away from the VOR. And as you're flying, you need to also keep an eye on the needle, adjust a little. If it goes a little bit to the left, you're going to head a little bit left until you bring it back into the center, and then you come back to the same heading that you selected, whether it's inbound or outbound. Okay, now you're flying, and let's do another exercise. And you've been instructed by ATC to intercept, let's say, radial 270. Let's make it a little bit harder. There's no need to select like east, west, north, and south. Let's say you've been instructed to intercept radial 250 inbound. 250 inbound. Great. I tune in and identify. Station's operational. 250 inbound. Put in the 250 on the top here. Here we go. 250 inbound. So I need to intercept this radial and then go towards the VOR. So I'm going to go opposite of that, which is 070, as you can see here on the bottom. So I need to intercept this radial the actual physical radial right here, and then actually turn towards the VOR. Where am I? Very simple. I need to turn the OBS until I get a from indication, and needle centered. I know now if I do this to say I don't know where I was at, and I go ahead and turn it, and here we go. It's centered. I am on the 180 radial. Very good. I come back here. I am on this radial, and I need to intercept this guy inbound. We know the rules of 30 degrees, 60 degrees, and so forth. Okay, what is 30 degrees from 250? Is 10, 20, 30. Here we go, 220. And another 30 degrees. Here we go, 190. So first thing I need to do is to fly parallel to this radial until I hit the 60-degree difference from that radial that's selected, which is right here, which would be the 190. So I need to fly in the direction 230. I'm going to turn 230. I'm sorry, 250. Okay, so I need to turn in the direction of 250 until I intersect the 60 degrees from the 250, which is right here, the 190. So I come back up, change this to 190. The next step, here you go. What happens when I intercept this radial? When I intercept the 190, I'm gonna go perpendicular to it. What is this direction? Don't have to do any math. Look here. This direction is 340. 340. Needle is centered. I'm going to turn to 340. It's coming to the center. I'm going to start turning. So I intercepted this guy. Now I'm going this way until I'm 30 degrees from 250. That's 220, and then I'm gonna go 45-degree angle to intercept this guy inbound. What is 45 degrees this way? Don't need to do any math whatsoever. Here we go. It's direction 025. 025 is coming this way. So when I hit the next radial, the 220, I'm gonna go ahead and put it on the top. Here you go. Here's my 220. I'm going to come at it with 45-degree angle this way at the one I need to intercept, which is 250 inbound, and that is heading 025. So wait till the needle is coming to the center. I'm going to turn to heading 025 for the final step of intercepting 250 inbound. Here we go. Now the needle is starting to move to the center, and at that point I'm going to turn two directions 025 in order to intercept my my inbound radial of 250. So I'm going to I'm here now. I'm almost coming to this radial. I'm going to now turn to come this way and intercept and go inbound. Okay. Okay, so now I'm coming at my radial now with this angle, so I'm gonna go ahead and select it. Remember, it's 250 inbound. So once I get close to that one, then you'll start to move to the center. 250 inbound. That means I need to turn in this direction towards the VOR, which is 070. You can actually keep the radial here and turn to 070, or you can actually pick that as a 2. So instead of a from radial, it's a 2, and we can select here 0702 that we need to intercept, and that would be the 250 inbound. 250 inbound. Alright, we'll wait until the needle starts to move to the center, and once we get close, we're going to start to turn to 070 until it's centered, and that means we have intercepted radial 250 inbound, 250 inbound towards the VOR station. Okay, now we can see the needle is moving. We're going to intercept our radial. It escaped a little bit. That's okay. What happened was I was so it's a little bit to the right. We have a 4-degree difference. That's fine. We're gonna go ahead and go a little bit farther, more than 070, and then we'll get it back in the center again. And it's a good exercise to learn how to adjust. Now it's back. It's coming back. As you can see, it's coming back to the center. And as it gets closer, we're going to turn to 070. Here we go. Okay. Anyways, close enough. We're close to the station, as you can see. That's why the needle is erratic. But we look at the map now to see what we've done. Here we go. Here's the map. We've been instructed to intercept, I believe, radial 250 inbound. We went when between the 30 and 60 degrees, we went A-beam to it. Then when we intercepted, we came at 45 degrees until we intercepted the radial that we're looking for, according to the rules that we have talked about. Okay, so you can see here, these are very nice interceptions, looking at the map. We didn't need to look outside. We didn't need to use a GPS. Nothing. All we did was use the ADF as our dial, not actually the ADF itself, but the actual little any dial on the plane that's not operational, not being used at the moment, can be used as your cheat sheet to follow the rules. And you can see how nice these interceptions have been. We're not using a GPS. We're just barely following the rules we studied earlier and implementing them, as you can see here. Okay, so I can definitely do more exercises in future videos, but I think I've illustrated capturing how to capture or how to intercept outbound and inbound radials properly. And let's go over the steps again very simply, and I'll explain to you here how you would do these steps using the different dials on the plane, the CDI and the ADF and so forth. So first thing, you're going to tune in and identify the station you're supposed to intercept the radial for. Once you do that, you tune in, you identify, you can listen to the Morse code, and you make sure that it's operational. You go ahead and put the radial that you've been instructed to intercept on the top here. And once you do that, whichever it is, let's say for example you're instructed to intercept 210 inbound or outbound, it doesn't matter, you just put it on the top. After that, you need to find out where you are. The way to find out where you are is simply by coming up and turning the OBS until you get a from indication, and you look and your needle is centered. I am now currently on the, for example, the 075 radial. So this is the one I need to intercept, whether it's outbound, going away from the VOR station, imagine the center being the VOR, or inbound towards the VOR. I am on the 075 radial, which means I'm somewhere here. I'll follow the rules from the previous slides about inbound and outbound radials interceptions based on where I'm at, what I need to do, and all I need to pretty much think about here is just to look at these directions. If I need to go this way, it's 210. If I need to go to the right, it's 300. If I need to go 45 degrees this way, well, it's right here for me. It's like 250. I'm sorry, 255. And all these directions are given to me, and I need to know, and I need to know where to turn before intercepting the next radial. And if there are steps into the interception, like for example this 60-degree radial from what I need to intercept, or 30-degree radial from what I need to intercept if it's an inbound, as you've seen before, in order to know where I'm at or how I'm going to get to it, you just center it here till I'm on it, then I do the next step and I know which direction I need to turn into. Simple as that. That is the way to do it in the aircraft on the fly, and in order not to get distracted with other tasks, because you need to be monitoring your gauges, altitude, heading, and so forth. Okay, thank you very much. I'm looking forward to getting some feedback, and I'll be more than happy to create more videos in the future if there's enough feedback or enough interest on learning about this more. So this summarizes, pretty much covers everything I need to talk about with regard to VORs. Thank you very much, and thank you for watching. Bye-bye.